Good morning to everyone. Today we are going to see about 20EC 504 digital signal processing subject. The unit 1, discrete Fourier transform. In that discrete Fourier transform we are going to see about discrete signals and systems, a review, introduction to DFT, properties of DFT, circular convolution, filtering method based on DFT, FFT algorithm, decimation time algorithm, decimation frequency algorithm, use of FFT in linear filtering. We know that we have to analyze, we have to study about signals in system. It is in review we want to discuss now. The signal means you know that it is one of the physical quantity. It varies with time and space. It may be a temperature. It is an independent or dependent variable. Here generally we have to define a signal as it is a function of one or more variable which conveys the information. Example, radio signal, TV signal and telephone signal. Classification of signal: continuous time signal, discrete time signal, periodic and aperiodic signal, even and odd signal, energy and power signal, deterministic signal and random signal, causal and non-causal signal. In discrete time signal processing, it means a digital signal processing, we are going to take about the only digital sample. It means that the discrete domain x of n, so that it is called as a digital signal processing. In that we have to see about the butterfly structure. Basically we know the butterfly structure: decimation in time and decimation frequency. In the decimation in time, we are concentrating input signal as in the same order. In decimation frequency, input signal in the reverse order. It means that bit reversal we will have to follow in that DIT method. Bit reversal means x of 0 0, again it is in 0 0. The bit reversal is same to our common method. And 0 1 we have to convert it is in 1 0, it is in bit reversal. So we have to write about 2 bit variations, means we have 4 combinations 0 1 2 3. In the bit reversal we have to get 0 1 2 3, so that we have to write in this problem in bit reversal order we have to write in the initial. After that, the one more point, Twiddle factor, it is in omega k nk, it is in Twiddle factor value. Suppose we are using the 4-point DFT, we can use omega 4 power nk. If the initial means it is in 0 0, and the next line means it is in omega 4 power 1. It is in Twiddle factor, we have to multiply in front of are the method, and finally we are getting the order 0 2 1 3. It is an normal order. 0 1 2 3, it is in normal order. In the same method we have to follow in the matrix also. We have to find out the DFT and IDFT. We have the difference between DIT and DFT. It is in time domain is sequence is decimated. Here the frequency domain sequence is decimated. The input is arranged in bit reversal order. The input sequence is arranged in natural order. Output sequence is arranged in natural order. Here in DIF method, output sequence are arranged in bit reversal order. Here we have to consider the total arithmetic operations or n log to n, complex addition, and n by 2 log to n, complex multiplication. Here we have a complex addition n log to n, and n by 2 log to n is a complex multiplication. Here n log 2 complex addition, n by 2 log to n complex multiplications we have in DIT and DIF method. We want to compute 8-point DFT of the sequence. We have to consider x of n. In the given data we have a 8 number of sample. We have to assign it is in here the arrow mark is in -1. So these are all the data. 0, it is in -1. Here n equal to 0, it is in values in -1, -1, -2, -3, -4 and -5. Here we have to follow the 0 to 8 sequence. So we have to find like this. This is a formula to find out the discrete frequency sequence, discrete time frequency of the sequence, discrete Fourier transform. x of k which is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi k n divided by n. From this formula we have to understand k value is in 0 to n minus 1. We have to follow the 0 to n, we have to substitute n, k value is in 0 to n minus 1, we have to get a number of sequences up to x of 7. We have to, in a correct order, we have to write out the x of k. It is nothing but an Fourier transformed output of the input signal. We have to find out the Fourier transform of the input signal because of we are converting time domain into frequency domain of the signal. It is necessary to analyze the particular signal. So only we have to attain a more number of beneficial characteristics from the frequency domain of the signal. So only we are converting analog signal into the digital signal, it may be, and also time domain signal into the frequency domain of the signal. Frequency domain of the signal possesses more characteristics, so we have to find out the Fourier transform of the signal. Here discrete Fourier transform we found. Thank you.